Welcome back, listeners, to another episode of Operating Systems Crashcast. I'm Victor, and with me as always is the wonderful Sheila. Today we're diving into the fascinating world of CPU scheduling algorithm evaluation. Sheila, are you ready to break this down for our audience?
Absolutely, Victor. I'm excited to explore this topic because it's crucial for understanding how operating systems make decisions about which processes to run and when. So, let's get started by discussing why we need to evaluate scheduling algorithms in the first place.
Great point, Sheila. Evaluating scheduling algorithms is essential because it helps us determine which algorithm will work best for a particular system. We need to consider factors like CPU utilization, throughput, turnaround time, waiting time, and response time. But how do we actually go about evaluating these algorithms?
Well, Victor, there are several approaches to algorithm evaluation. Let's start with the simplest one, deterministic modeling. This method involves taking a predetermined workload and defining the performance of each algorithm for that workload. It's straightforward but has limitations. Can you elaborate on that?
Certainly. Deterministic modeling is like having a perfect recipe with exact measurements. It's great for comparing algorithms under specific conditions, but it doesn't account for the variability and unpredictability of real-world scenarios. That's where more advanced methods come in, like queuing models.
Exactly. Queuing models are a step up in complexity. Imagine a busy restaurant, Victor. Customers, processes, arrive at random times, and the chef, CPU, serves them. Queuing theory helps us analyze how long customers wait, how efficiently the chef works, and how many customers the restaurant can serve. In the context of CPU scheduling, it helps us understand system behavior under various conditions.
That's a great analogy, Sheila. Queuing models allow us to calculate average queue length, average waiting time, and average utilization. However, they often require certain assumptions that may not always hold true in real systems. That's where simulations come into play. Can you tell us about those?
Of course. Simulations are like creating a virtual version of our operating system and running experiments on it. We can program the behavior of different components and test various scenarios without affecting a real system. This method is particularly useful for complex systems where analytical solutions are difficult to obtain.
Absolutely. And the best part about simulations is that we can adjust parameters easily and see how changes affect performance. It's a powerful tool for OS designers. But there's one more method we should discuss: implementation and measurement. This is where the rubber meets the road, so to speak.
Indeed, Victor. Implementation and measurement involve actually coding the algorithm into an existing operating system and measuring its performance in a real environment. While this provides the most accurate results, it's also the most time-consuming and potentially disruptive method. Many tech companies use this approach to fine-tune their systems, though.
That's right, Sheila. Companies like Google, Amazon, and Microsoft invest heavily in algorithm evaluation to optimize their massive computing infrastructures. It's not just academic, it has real-world implications for performance and cost efficiency.
Absolutely. Now, for our listeners who might be preparing for interviews, it's important to understand the pros and cons of each evaluation method. Deterministic modeling is simple but limited. Queuing models provide good insights but rely on assumptions. Simulations offer flexibility but may not capture all real-world complexities. And implementation gives the most accurate results but is resource-intensive.
Great summary, Sheila. And remember, the choice of evaluation method often depends on the specific needs and resources of the system being designed. It's about finding the right balance between accuracy, complexity, and practicality.
Exactly, Victor. Now, as we wrap up this episode, let's quickly recap the key points we've covered in this chapter on CPU scheduling. We've discussed basic concepts, scheduling criteria, various scheduling algorithms, thread scheduling, multiple processor scheduling, real-time CPU scheduling, and finally, algorithm evaluation methods.
That's right, Sheila. CPU scheduling is a critical component of operating systems, affecting system performance, user experience, and resource utilization. Understanding these concepts is crucial for anyone working in operating systems or preparing for related interviews.
Absolutely, Victor. And with that, we've come to the end of our chapter on CPU scheduling. In our next episode, we'll be moving on to a new and equally fascinating topic in operating systems. Stay tuned.
Thanks for listening, everyone. We hope you found this episode informative and engaging. Until next time, keep exploring the incredible world of operating systems.